Good afternoon. My name is Daniel Manzanilla, and this is my presentation for my final stage of my key activity. So let's begin. So in this semester, we have seen 2D and 3D vectors, how to calculate its magnitude, the vectors, and the different representation equations they have. For my key activity, I chose 2D vectors, and they only have movement in 2 axes, and the 2D vectors can be seen in polar form or in rectangular form. So to understand more, a vector is a quantity that has a magnitude and direction. In real life, we can see or understand the vectors with the movement of objects. For this project, my question is, how does the surface affect the movement of an object? I will use the formulas for 2D vectors to analyze the results. For my variables, we have that my independent variable will be the surface, my dependent will be the time, my control variable will be the magnitude of the vector we take, and my hypothesis is the surface does affect the movement, the surface will affect the movement of the object, giving them different time values, okay? So the experimentation. To start the experiment, I chose one of my shoes. I made a homemade Cartesian plane of 1 meter times 1 meter. I moved the shoes at 40 degrees for each 1 meter with the same force, and I recorded the time. So I moved the shoe at 40 degrees, 1 meter each try. I did the experiment twice for each platform. First, I moved the shoe on a mosaic floor that is smooth with just few imperfections. Then I moved it on the street floor with lots of imperfections, that it's called a rough platform. Let's see the video of the evidences. Hello, I'm Ella. This is the video for the evidences of the key part. Oh my God, sorry. Let me show you with sound very quickly. Okay. Hello, I'm Daniel Manzanilla. This is the video for the evidences of the key activity part 2. Okay. So yeah, this is the Cartesian plane I used. As I told you before, 1 meter, 1 meter, and I measured 40 degrees to move the object in 1 meter. Okay. Shoe I used. This is the shoe I used. It is. This is the smooth platform that is the floor of my house. It's very smooth. The street. This is the street floor. We can see all the imperfections right here. And let's go. This is our second try. As you can see, already you can see that I take a lot of effort to move it like with the same direction, because the floor was very, very, very rough. So the floor doesn't let me move it like I wanted to. This is a smooth one. As you can see, there was no effort to move it. All right, so let's begin. This is our results. On the first try, we get that 6.7 seconds on the smooth platform. On our second try, we have that it was 7.3 seconds. On the other side, we have the rough platform. In the first try, we did 9.5 seconds, and in our second try, we have 8.6 seconds. We can see already a big difference in time with the rough and the smooth platform, with an average difference of 2 seconds in each try. So let's continue. This is our calculations for the vector. So to transform it in rectangular form, we have to multiply it first with cosine to represent the x-axis in rectangular form, and in y we have to multiply it with sine. Okay, and when we did the calculations, we did the sum here, and we get 1.532i in the x plus 1.284 in j, that it's y. We take out the magnitude of the vector, that is 2. Why do we have 2? It's very simple, because as you remember, we did twice the experiment in each platform, and that's how we get the vector, the magnitude of the vector. So we moved it 1 meter each time. 1 meter plus 1 meter, well, we have 2 meters. Here we take the angle, well, we didn't need it, but it's to check it if it was correct, and it was correct. Tangential -1, and multiplied by the division of y over x. we get 40 degrees, okay? So I repeated the experiment twice in each platform. And when comparing the results, we can see that the average difference in each try is 2 seconds, as I told you before. The shoe lasted 2 seconds more moving on the street floor than in the smooth floor. My hypothesis said that the floor does affect the movement of the objects, giving them different time values when they moved in a certain distance. So with this experiment, we can say that my hypothesis was true. For exact results, I would have used in this experiment a chronometer for taking the time the shoe moving in the different floors more exact than in my phone. It also needs something that pushes the object with the exact same force, because no matter how we try, we cannot push the object with the same force twice. There will always be variances. To end, I would have changed the object to use. I used a shoe, but if I had used something more symmetric, the results would have been more clear. So yeah, that was all, folks. And I hope you liked my presentation. I really like this experiment because it let me use something I learned from the school in real life, and that was very exciting. Thank you very much.